Hey, my peeps, it's me. It is Wednesday or Thursday, depending on when you're listening to this. So we're moving on to 5.2, and I think it actually may be a little bit better for you because you have to prove what it is proving trig identity. So I'm not just asking you to simplify. What I'm asking you to do is simplify, and then you're checking that it is the same as the other side. So it's a little bit more direct, and you know what answer you're supposed to be getting to. So I have a couple of notes here. You can either print my answer key notes out, which is this with my writing. I also uploaded blank notes so you can write what what I write or say, whatever. It's up to you. You don't have to send anything back to me in terms of the notes, but however you want to do your notes is fine with me. So it just says prove that. Okay, so I have tan squared plus sine squared plus cosine squared is equal to secant squared. So the first thing we talk about is that we want to simplify the more complicated side. Okay, that includes fractions, adding, subtracting, anything like that. That's definitely the more complicated side. And you are only allowed to do anything to that side. You're only allowed to simplify that side. You are not to do anything to the other side. So do you see what I wrote there as well? Okay, so let's actually do it. So if you notice that sine squared plus cosine squared, look, I wrote it down here. Sine squared plus cosine squared, at this point, I hope we know that that equals 1. So you get tan squared theta plus 1. Well, this tan squared theta plus 1 is one of our identities. That's one of our, that's something that we use on our cheat sheet, from our cheat sheet. And tan squared theta plus 1 is secant squared theta. So we did it. That was it. That's all you have to do with that one. That's all I'm looking for there. Okay. Okay, let's go to the next one if you have the notes in front of you. Or not, we're moving to here. And this one I feel like you could try, actually. I know we've only done one so far, but I feel like if you simplify this side, why don't you do this? Why don't you pause for a minute, start distributing that cosine and see what you can come up with, okay? All right, pause it, go. Okay, so this is what you should have come up with. Let's take a look. You're going to distribute your cosine. So cosine times secant minus cosine times cosine, of course, is cosine squared. That's where we're getting that from. Okay, so let's keep going. Well, I know I'm going to change my secant, of course, to cosine. So I'm going to write cosine times 1 over cosine. And then I still have that minus cosine squared hanging out. Well, now that I have cosine times 1 over cosine, I can cancel that out. And I'm left with 1 minus cosine squared. And again, go back to your cheat sheet, right? We know that 1 minus cosine squared is sine squared. Perfect. Got it. That side has to equal the other side exactly. And that's it. All right. No, that's it. I mean, there's more to it, obviously. So let's get ahead to another example. So this is, of course, our more complicated side because we have subtraction and we have a fraction. Okay. So if you go back, if you recall from what we did with simplifying, is we're using a conjugate here. Okay. 1 minus, everything is in sine or cosine. So we're going to use the conjugate. So we're going to multiply by 1 plus cosine theta on this side only, remember. And we're going to do 1 plus cosine theta on the top and the bottom. Okay, so let's take a look at my work here. And there we go. So I'm going to multiply again. This is your conjugate, this 1 plus cosine. It's the same exact thing, except it's a different sign in the middle. Okay, and from here, what are we going to do? Well, we're going to distribute everything. So the top gets distributed, right? Sine squared times 1 and sine squared times cosine. And the bottom gets either, however you look at it, as FOILed or distributed, right? So on the top, you should have gotten sine squared plus sine squared times cosine. If you FOILed this, sorry, if you FOILed this all out, you should get 1 minus cosine squared. Okay, and what is 1 minus cosine squared? You know it. You got this. Sine squared. Great. So now I'm left with sine squared theta, cosine theta. I mean, anything from this numerator to this numerator. All I did from this step to this step would change 1 minus cosine squared to sine squared. Hopefully you're seeing something now what I can do from here. When you have a fraction like this, it's best to separate the numerator, okay? It's best to separate the numerator. And the reason I'm going to separate the numerator is because of that fraction sign. So what it looks like is sine squared over sine squared, right? This numerator over the normal denominator. And then I'm going to add this numerator over the denominator again. Well, what happens here? Look at my sine squared divided by sine squared. Yes, it cancels out, but it doesn't become 0. Be careful with that. It becomes 1 plus, and then sine squared over sine squared cancels each other out. and you're left with cosine. Well, what did I want to prove it? 1 plus cosine? Oh, perfect. Look at that's 1 plus cosine. All right, let's go back up here if you need me to. You can pause it at any time if you want to look at it. All right, let's go. You're doing great so far. So here we go. Again, look, this is the more complicated one. I circled this one already. However, it goes back to the example that we just did. Very similarly, in the constant, the only time we do the constant is if it's on the bottom. Okay, if that this cosine plus 1 was on the bottom, then we would do the constant. If it's not, well, what are we going to do? What I said before, because you have that plus sign, let's separate the numerator. So when I separate the numerator, I don't know if how much I want to show you that, sorry. Oh, come on. Okay, there we go. I separate the, oh my God, there. I separate the numerator, and what happens? I get cosine over cosine, right? Just cosine over cosine, plus 1 over cosine. So what's cosine over cosine? 1. And what's 1 over cosine? We can write that as secant. And there you go. You got it. That was it. There we go. All right, this becomes the 1. This becomes the secant, and that's exactly what I wanted. All right. Okay, I'm going to keep going because I feel like it's not great so far. Okay, this one, let's look at. We're going to do this one. We're going to simplify this one because it has the addition, multiplication is easy. We can't simplify it all that much. So this is the more complicated one. Okay, so what are we going to do with tangent and cotangent? Let's change everything to sine and cosine. Let's not forget about, going like the basics. How to simplify. So I'm going to change it to sine and cosine. There's tangent right here. This is my tangent, and this is my cosine. Okay. And then what I did next is I'm going to find a common denominator. Okay. Again, going back to the simplification process. So my common denominator would be these two added, these two multiplied together, cosine sine. Okay. So if I do that, I need to multiply by sine on the top and the bottom over here. I need to multiply by cosine on the top and the bottom over here. So what do you get when you do that? You get sine squared plus cosine squared over sine cosine. And we know this now, right? What is my sine squared plus cosine squared? Not as soon as I do it on the board. And we know that that's 1 over, and let's combine that and denominators right together, so it's only 1, right? So 1 over sine cosine. Okay, well from here, what is 1 over sine? We can rewrite 1 over sine as cosecant, and we can write 1 over cosine as secant. And what I did there, I separated it. And there you go. So what do I want to prove it? Perfect. Secant, cosecant. Right? Cosine, 1 over cosine is really the secant. It's a different order. And a 1 over sine is really the cosecant. Again, it's just a different order. All right. That's that one. I'm going to keep going. All right. I think this one I got to try. So I'm going to pause it for a second. I'm going to start the ones you need and then come back to me. Okay. All right, you're back. So let's see what you got. I made secant 1 over cos, and I made cosecant 1 over sine. Well, I know that when I what do I do? When I divide fractions, I keep, right? I keep 1 over cosine. I change the division to multiplication, and I flip the second fraction. So it looks like this: 1 over cosine, keep, change multiplication, flip the second fraction. Keep, change, flip. This becomes sine over cosine, and what is sine over cosine? Well, that's if you need some, but I think hopefully we know that by now. Sine. And perfect. Check that. That's what we wanted. Good. So far, so good, I hope. This one is, again, I put this as a try because what I want you to do is I want you to try using the conjugate. All right, so take as long as you need for that, pause it, and then come back to me. All right, if you're back, here you go. This is what it looks like. You're multiplying by the conjugate. All right, so then I'm distributing. I get 1 minus cosine squared on the bottom. When you distribute all this, that's what you should get. We know that that is now sine squared. And what am I going to do? I'm going to separate the numerator after I made 1 minus cosine squared sine squared. Then now I'm going to separate that numerator just to see it a little bit clearer, just so I know how to actually cross out. And what happens is I get sine over sine squared, which becomes 1 over sine. Sine and the squared cancel out, but this sine has to stay. So now it's cosine over sine. And what did it say I wanted? And that is what I wanted. Cosecant, 1 over sine is cosecant, and cosine over sine is cotangent. And that's exactly what I wanted to prove. So good to go. So again, the proving kind of helps a little bit, only because we know exactly what we want to get, rather than guessing like, oh, is this, did I simplify enough? We now know. This one I gave you, this one's a little bit more complicated, but if you want to try it, I'll show you the answer. So here it is. Pause it first if you want to try it and then come back to me. It's making a common denominator. So there you go. Give it a try. And that's how you get it. Okay. You can pause there to take a look at my answers. I also uploaded the answer key for these notes. Okay. So you can look at either of them. And I'm going to have a video check-in as well. All right. All right. Thanks, guys. Have a good day. Miss you all.